Hello students, welcome back to physics class. In today's class, we shall discuss an exciting topic to understand how the objects behave when they are in motion and how the force affects on them. So let us begin with linear momentum. Linear momentum. To understand the concept of linear momentum, let us first of all consider an example. Consider two different bodies, say body A and body B. So the first body be named as A, the second body be named as B, which are moving with same velocity. So let us consider two bodies A and B moving with velocity V in the same direction. Okay, and let us also suppose that the mass of A is greater than the mass of B. So that means the first body A is heavier when compared to the second body B. Okay, so now what we observe is the force required to stop the heavier body, that is first body, will be large when compared to the force required to stop the lighter body, that is B. That means the force required to stop the body A is greater when compared to the force required to stop the body B. So from this we can conclude that the quantity of motion of a body is directly proportional to the mass of the body. What we observe is, so heavier the mass, heavier the force required to stop the body. Lighter the mass, lesser will be the force required to stop the body. So the quantity of motion of a body, both are set into motion because they both are moving with velocity v. So the quantity of motion of a body is directly proportional to the mass of the body. So this we have considered in the case 1, first case. Okay, I'm just giving you an example that where we need to consider two different bodies, say A and B, moving with velocity v. Okay, the mass of A is greater when compared to the mass of B. Now, what we observe is the force required to stop the heavier body will be larger when compared to force required to stop the lighter body. That is, force A is greater than force B. Okay children, hence from this we can conclude that the quantity of motion of a body is directly proportional to the mass of the body. I repeat, the quantity of motion of a body is directly proportional to the quantity of, mass of body. Moving with second example, so let us consider case 2 children. Okay, case 2. In this, what we try to understand is, again let us consider two different bodies, say A and B, which are moving with two different velocities, say VA for first body and VB for second body. So let us consider two different bodies, okay, are moving with two different velocities VA and VB respectively in the same direction. Okay, so here also we conclude that the speed of first body A is greater than the speed of second body B. That means in the second example we have considered that the first body is moving faster when compared to the second body B. Okay, so here whenever the body means the force required to stop the faster body will be greater when compared to the force required to stop the lighter body. So here we can observe that the force required to stop the faster body is greater when compared to the force required to stop the slower body. So from these two we can conclude that the quantity of motion, again here also they both are set into motion, earlier example also they set into motion, the quantity of motion of a body is directly proportional to the mass here, and here the quantity of motion of a body is directly proportional to the speed or velocity of a body, directly proportional to velocity of a body. So from the two examples we can understand that the force required to stop the heavier body is greater when compared to the force required to stop the lighter body, and the force required to stop the faster body is greater than the force required to stop the slower body. That means from the two we can conclude that the quantity of a body depends on two factors. One is mass of the body and the other is velocity of the body. That is, the quantity of motion of a body depends on two factors. What are the two factors, children? One is mass of the body, the other is velocity of the body. So let me write it here. So the quantity of motion of bodies depends on two factors. What are the two factors? First one is mass of the body and the second one is the velocity of the body. Velocity of the body. So these two factors the quantity of motion depends on. Okay. So in order to stop the motion we need to apply force. Okay, children. So from this we can conclude that the quantity of motion of bodies, okay, possessed by the body, the quantity of motion possessed by the bodies is nothing but your momentum. The quantity of motion possessed by the bodies is nothing but momentum. Just a meaning of that. What is momentum is how much motion is capable of a body. Okay, the quantity of motion possessed by a body is simply called as your momentum. So in order to understand properly regarding the mathematical form of this momentum, so our main concept is all regarding the momentum. So to understand the real concept of momentum, let us go with the application part, that is momentum mathematical form. Okay, mathematical form. Okay, children. So suppose that let us consider a body of mass m, initially moving with velocity v. Okay, then the mathematical form is defined as said. That means if m is the mass of the body and v is the velocity of the body, then the product of mass of the body and velocity of the body is equals to the linear momentum of the body. The product of, if v indicates the velocity of a body, m indicates the mass of the body, then the linear momentum p is defined as the product of mass of the body and velocity of the body. Children, you would have observed that here I kept bar over here. This bar indicates whenever we represent a vector quantity. Here velocity and momentum are vector quantities. So to represent the vector quantities, I often write this bar over that, but mass is a scalar quantity, hence I no need to write any bar over that. Always vector quantities are represented by bar overhead. Okay, children. So this is the mathematical form of linear momentum. Linear momentum p bar is nothing but p, simply p is nothing but the product of mass of the body and velocity of the body. Okay, children. So moving ahead, let me write it once again. P bar is equals to mv is the mathematical form of linear momentum of a body. So, and always remember that the momentum p means momentum. So this momentum is a vector quantity. Momentum is also a vector quantity. That means it has both magnitude as well as direction. Momentum is a vector quantity. So children, coming to the units, SI units of momentum. So in order to find the SI units of momentum, so as you know, the formula for momentum is mass into velocity. What is the SI unit of mass, children? So SI unit of momentum is nothing but, here product of the two factors, one is equals to SI unit of mass multiplied by, this is velocity, SI unit of velocity. That's all, children. Hence the SI unit of momentum, the SI unit of momentum P is equals to, SI unit of mass is measured in kgs and unit of velocity in measured in meter per second. SI unit of velocity is meter per second. Hence the SI units of momentum is kg meter per second. That is, the SI units of momentum is kg meter per second. So this you need to remember, children. So the units of momentum is kg meter per second. Similarly, if you would like to write down the CGS unit of momentum, then this can be written as like this. Okay, kg means SI units. Instead of kg in CGS system, the mass is measured in grams. Meter in SI system. The same thing in CGS system, instead of meters, we write it as centimeters. And second, as usual. So the CGS unit of momentum is gram centimeter per second. Okay, children? So the mathematical form of momentum is P is equals to mv, where P is a momentum, m is mass and v is velocity. And remember that velocity is a vector quantity and momentum is also a vector quantity. That means it has both magnitude as well as direction. SI unit of momentum is kg meter per second and CGS unit of momentum is gram centimeter per second. Okay, children. Now, before concluding, let us also try to understand the other concept, that is change of momentum. What is the next topic, children? Change of momentum. So what is change of momentum? Let us suppose that, consider a body moving with initial velocity u. So we need to consider a body of mass m. So initially moving with velocity u. Whenever a force is applied on it in the direction of its movement, then its velocity after certain time, okay, because of some application of force, its speed may increase, okay, because force is being applied. So initially moving with lower velocity, some initial velocity u. Now as the force being applied in the same direction of motion, its velocity may be changed to some v. Then the final velocity of the body be v. Initial velocity of the body is u and final velocity of the body be v. Okay, that means what is the initial momentum? Momentum indicated with the letter P, children. Initial momentum, let me name it as Pi, initial momentum. It is a vector quantity, Pi bar, equals to how much? Mass into velocity of the body. Mass into velocity. How much velocity? Initial velocity u. Because it is a vector, let me write it as mu bar. Similarly, in the case 2, what I can write it is momentum, final momentum of the body leg, represented by PF. It is a vector quantity bar, equals to mass into final velocity of the body, that is mv bar. Now in order to understand the change in momentum, can be written as, the symbolic notation be some delta. Change always indicated with the letter delta. Like this, children. So change in what? Change in momentum, delta P. So this delta P can be written as change. Initially some momentum was there, final momentum something else there. So change means final momentum minus initial momentum. What is the change? Final momentum minus initial momentum. So what is final momentum here? PF is given as mv bar minus initial momentum was mu bar. So this is your change in momentum. Also you can take out m as common, then you are left with v bar minus u bar. Hence change in momentum can be written as m into v bar minus u bar. Okay, children. So let us recap once again. So what we have considered is the quantity of motion of a body is directly proportional to mass as well as directly proportional to velocity. So this mathematical form of the momentum is represented as P is equals to mv, SI units is kg meter per second and CGS units is gram centimeter per second, and change of momentum can be written as delta P equals to mv minus mu, or simply m into v minus u. So based on this concept, let us try to solve few numericals. Okay, so here goes the first numerical from worksheet number 3. The linear momentum of a body of mass m and velocity v. So linear momentum, what is that, children? Mass, linear momentum indicated with the letter P. P is equals to, what is the formula I told? Mass into velocity. Here the proper representation is bar should be get, because just to indicate it is a vector quantity. But here, or simply known, if you won't need to rate whether it is a vector or scalar, simply it can be written as P is equals to mass into velocity. The product of mass and velocity gives a momentum. So where is the correct answer? Fourth option is true. Okay. So the linear momentum of a body of mass m and velocity v is given by P is equals to mv. Your right answer is fourth option. Moving to the second question. The physical quantity which is the product of mass and velocity of a body is known as. What is the product of mass and velocity? Is nothing but just now we discussed product of mass and velocity. mv is nothing but momentum. So second answer. Next, which of the following is the unit of linear momentum? Just now we have discussed linear momentum P is equals to mass into velocity. So units of mass, SI units of P, if you want to write, means mass is measured in kg and velocity is measured in meter per second. So, or it can also be written as something like this, kg meter per second can also be written as second inverse. So where is the proper answer, children? Here goes your right answer, kg meter per second, kg meter per second. So first option. Moving ahead. Question number 4. What is the momentum of a man of mass 75 kg when he walks with a uniform velocity of 2 meter per second? So what is given data, children? Mass is given as well as velocity is also given. You are asked to find out the momentum. So momentum formula, what is formula for momentum? Product of mass and velocity. Momentum is nothing but the product of mass and velocity. So P, you are asked to find out how much mass is given, 75 kg, and how much velocity is given, 2 meter per second. Hence the momentum is equals to 75 into 2 is 150. What is the units of momentum in SI unit? Kg meter per second. So 150 kg meter per second. Third option must be true. Okay. Next. What will be the momentum of a toy car of mass 200 grams moving with a speed of 5 meter per second? Again, mass is given and speed is also given. So momentum is nothing but product of mass and velocity, or mass and speed. The same direction is considered. So hence mass, how much mass was given, children? 200 grams. 200 grams was given. Okay. So let me write out, because units are different, because here it is given in a CGS system and here it is given in SI system, but options are given in SI system. So first of all, let us try to convert. Mass is given as 200 grams. So mass, grams, if you want to convert in kgs, what you need to do is divide it with 1000. Now it will become kgs. Okay, 1 kg is 1000 grams and 1 gram is 1 by 1000 kg. So 200 grams is 200 by 1000 kg. So further simplification gives this zeros will get cancelled. 2 goes upon 5, that is 1 by 5 kg. And what is the speed given? V is given to be 5 meter per second. 5 meter per second. You are asked to find the momentum. So momentum is equals to mass into velocity. How much mass given, children? 1 by 5 kg into how much speed is given? 5 meter per second. This 5 and this 5 get cancelled. 1 into 1, how much? 1 kg meter per second is your right option. First one, 1 kg meter per second. Moving ahead, question number 6. A body of mass 25 kg has a momentum of 125 kg meter per second. What is its velocity? Children, we know the formula momentum is equals to mass into velocity. What is given? Body of mass is given as 25 kgs. Momentum is given as 125 kgs. Given condition, mass is equals to 25 kg and momentum P is equals to 125 kg. This is known, this is known. What you are asked to find out? Velocity. So in order to find the velocity, we have bring this mass the other side. Then P by M will be equals to V. To find the velocity, bring the mass the other side, then that will go to denominator. So V is equals to P by M. So after substituting, V can be written as this. Velocity is nothing but momentum. What is momentum value? P equals to 125 kg upon how much mass was given, children? 25 kgs. Okay, so 25 5s 125. Hence the speed or velocity of the car, what is that? Body of mass. Okay, how much is that? 5 meter per second. So answer is second option. Okay, momentum equals to mass into velocity. Velocity equals to momentum by mass. Momentum 125, mass 25. So 5 meter per second. Next question, a cricket ball of mass 100 grams is moving with velocity 25 meter per second. Here again 100 grams in CGS system, velocity is given in SI system. So again you are asked to find the momentum. So same old formula, momentum is equals to mass into velocity. What is given, children? Mass is given as 100 grams. So to convert this in kgs, you have to divide this with 1000, then it will be kgs. 1 gram is 1 by 1000 kg, so 100 grams is 100 by 1000 kg. So zeros will get cancelled, so you are left with 1 by 10 kg. And how much is the velocity given, children? 25 meter per second. So M is known, V is known. You are asked to find out momentum. Momentum is nothing but mass. Mass how much? 1 by 10 kg into velocity how much? 25 meter per second. So this is nothing but 25 into 1 is 1 into 25 is 25 and denominator you have 10 kg meter per second. So what is 25 by 10, children? The decimal goes here. This will be 2.5 kg meter per second. So answer will be third option, 2.5 kg meter per second. Now the last question, two bodies A and B of same mass are moving with velocity V and 3V respectively. Then the ratio of momentum is. Children, we know the formula for momentum is mass into velocity. So first one, mass is constant but velocity is changing. First momentum value, how much P1 is equals to? What is the first mass? Some M, let us suppose. If first body mass is M, then second body mass is also M because they have the same mass, M. And what is the velocity given, children? Velocity is given as V, that's all. So P1, let me write it like this, okay? P1 as P1 only, M1 as some M and V1 as some V. Okay? First momentum, second, first mass, first velocity. Velocity they gave it as V. Momentum we consider it as some P1. Mass, same mass means M. Similarly, P2 is some value. M2 same mass. So M. V2 how much they gave? 3V. So this is the given data. Now you are asked to find out the ratios of the two. The ratios of the two is nothing but P1 by P2. What is the value of P1, children? P1 means mass into velocity. How much mass into velocity? mv upon. What is P2? P2 means mass into velocity of the second body. How much? M into 3v. M gets cancelled, v gets cancelled. So answer is 1 by 3. Therefore, P1 is to P2 is equals to 1 is to 3. So that's all for today's class, children. So make sure to revise the formulas and practice well, and also try to observe the motion of the bodies or the examples of momentum in real life. Okay. Thank you. So, and let us meet in the next class. Thank you, children.